Hello my dear students, thanks to all. Today I will discuss about some special mathematical problems of moment of inertia. In our previous lectures we learned some of the important mathematical problems. Today I also discuss another some of the mathematical problems that will be very helpful for your final exam. Okay my dear students, my example is today's example is 1. At first I give you a problems, then we try to solve. Okay, suppose this is the circular disc. Okay, this is the circular disc. Okay, our duty is to find out the moment of inertia in case of the rotational axis passing through the center of the circle, and this is the rotational axis. Okay, and name of this rotational axis is PQ. My dear student, try to understand. At first we draw these problems here. Okay, this is the circular disc. This is the circular disc, and a rotational axis passing through the center of the circle, and this is the rotational axis, and this is the rotational axis, and the name of this rotational axis PQ, and this is rotate around these diagrams. Okay, the mass of the circular disc is 4 kg and radius is 12 centimeters. Okay, here also has another rotational axis. This is the another rotational axis. Okay, and the name of this rotational axis is AB. Now our duty is to find out the moment of inertia. At first, number of C problems. Moment of inertia in case of the rotational axis passes through the center and normal of the circle, and this is the PQ axis. Okay, and then number of D problems. What will be the ratio of moment of inertia? PQ is to IAB. Okay, this is our problems. Okay, my dear student, try to understand after how can we solve this type of the problems. Already we discuss all the rules of moment of inertia. Okay, now we try to solve. At first let we solve number 1 problems as solution 1. Okay, as the this is the circular disc and this is the rotational axis. Okay, and this rotational axis passing through the center. Okay, we know moment of inertia will be I is equal to PQ M R square divided 2. As the rotational axis passing through the center of the circle, because of that reason the equation will be I is equal to MR square divided 2, as this is the normal. Always try to understand this is the normal. So mass is how much the mass of the object? And the mass of the object is 4 kg and radius is 12 centimeter. Okay, the mass of the object is 4 kg and radius is 12 centimeter. So we write 12 centimeter converted into meter, 1 divided 2 whole square divided 2. Now our duty is to find out the value of moment of inertia. 4 into 0.12 whole square divided 2. Okay, the value is 0.0288 kg meter square. Okay, my dear student, I think that all of you clearly understands. Okay, now I try to add here another problems with this. Our problem is I is equal to PQ. So if this disc rotate around the this way, then moment of inertia will be I is equal to 0.0288 kg meter square. My dear student, I give you the another problems here. Just add here some of the problems so that you will clearly understand. If this circular disc rotate with 60 rpm, if the circular disc rotates 60 rpm, okay, if the circular disc rotate 60 rpm, what is meaning of the rpm? Rotational per minute. This means R means rotation, P means per minute. Okay, my dear student, I think that all of you clearly understand. Okay, I think that all of you clearly understand. Try to understand actually what is happened here. We know our duty is to find out the angular momentum. What will be the angular momentum? L is angular momentum. Okay, L means angular momentum. My dear student, always try to understand. Here has a equation of the angular momentum. We know L is equal to I omega. As we know the value of I, so we just divide omega. We know omega is twice pi n divided t. Why we write this? Because 60 rpm give us message rotation, number of rotation is 60 and time is 1 minute. 1 minute means 60 second. Okay, 1 minute means 60 second. Okay, now our duty is to put the value here. Already we find moment of inertia 0.0288 into 2 into 3.1416 and number of rotation 60 divided 60. So after solving we get the value here. The value will be 60 will be cancelled out, so 2 into 3.1416 and 0.0288. Okay, and finally we get the value 0.1809. The unit of angular momentum will be the angular momentum's unit will be, we know moment of inertia unit is kg meter square, and unit of omega is radian per second. So this is the unit of angular momentum. Another unit of angular momentum is, we also know this equation. I means m r square, omega means we know v is equal to omega r. So omega will be v divided r. So if we put the value here, so another equation of angular momentum will be mvr. Okay, this is the another equation to find out the angular momentum. In case of find out the angular momentum with the help of this equation, we need the mass of the object, and v means linear velocity, and r means angular radius of the circle. So kg, velocity unit meter per second, and distance mean meters. So another unit can be kg meter square per second. Okay, this is the another unit. Any of the unit you can put. Okay, actually our problems is this, I is equal to pq is equal to what? Okay, my dear student, try to understand. Our another problems is this ratio between the moment of inertia with respect to pq axis and moment of inertia with respect to AB axis. So already we find moment of inertia PQ axis. Now we solve question D. Question D will be solved by this way. Okay. My dear students, we know from C, I is equal to PQ is, we write the actual value is 0.0288. 0.0288 kg meter square. Okay, now our equation is, will be parallel. We just use here parallelism theorem for find out moment of inertia in case of the rotational axis AB. So we can write at first Ig plus m a square. This is the equation. Ig means PQ. Okay, why Ig means PQ? Because rotational axis passing through the center. Here this is the center of the gravity, and rotational passing through the center. So we can write moment of inertia Ig is equal to mr square divided 2. Suppose this distance is h and value of h will be given our problem. Suppose value of h will be 2 meter. So if we find out the moment of inertia along AB axis, then according to the parallel axis theorem, at first we write Ig plus m h square. Okay, this is our equation. My dear student, already we find out the value of Ig. Ig means 0.0288 plus m means 4 kg, right? Right, m means 4 kg. 4 into s means 2 centimeter. S means value of s is 2 centimeter. This will be given in our problem. So we can write 0.02 square. Okay, this is equation number, this is the equation number 1, and this will be the equation number 2. Okay, 4 into 0.02 whole square plus 0.0288. Then our answer will be 0.034 kg meter square. So this is equation 2. Now we divide these two equations. Equation 1, we divide equation 1 by equation 2. Okay, the value of equation 1 IPQ divided IAB. The value of PQ will be 0.0288 and value of AB 0.0304. okay, after dividing this we get the value 0.0288 divided 0.0304. okay, finally we get the value 0.947. okay, so we can write the ratio. I into PQ I into AB will be 0.947:1. This is the answer of this problem. My dear student, I think that all of you clearly understand, and if you understand these problems, then I think that it will be very helpful for you to solve any kind of the problem like this. okay, this is our problems. okay, from these diagrams I also give you another examples in our next sessions. okay, if you understand these problems, then I will go to the next problems. My next problems will be like this. Suppose these problems also very special. Example 2. okay, example 2. These problems will be like this. Suppose this is the cylinder. Suppose this is a cylinder. okay, and this is the rotational axis. This is the rotational axis, and this rotational axis passing through the center of the gravity, and the name of this axis is x prime. X prime is the rotational axis, and this is the direction of the rotation. Okay, and here this is the radius and this is the length. Length is L. Suppose the radius is 10 centimeter and length is 20 centimeter and mass is 4 kg. Okay, mass is 4 kg. My dear student, try to understand actually what is happened. Suppose this is the given problems. Okay, now our duty is to give you some information here. Suppose this is the another rotational axis. Okay, this is another rotational axis. Okay, I have to change this axis because okay, suppose this is the another rotational axis. Okay, this is another rotational axis. Suppose the distance from this axis and the center of the gravity has been given. Okay, suppose this distance will be h is equal to 15 centimeter and name of this axis is AB. Okay, now our question is like this. Suppose number C, find out the moment of inertia along x prime axis at first. Okay, our first question is find out the moment of inertia with respect to x prime axis. Okay, then find out the moment of inertia D if the object also rotate around AB axis, then what will be the change of the moment of inertia? That means change of moment of inertia. Change of moment of inertia. Dear students, let we try to solve these problems. Okay, this is our problems. Our problem is here has a cylinder. This is the solid cylinder. The name of this cylinder is solid. Okay, in case of the solid cylinder, okay, the radius of the cylinder is 10 centimeter and length is 20 centimeter and mass is 4 kg. And here we can see two rotational axes. One is x primes and another rotational axis is AB. The distance between the two perpendicular rotational axes is 15 centimeter. Now our first question is find out the moment of inertia along x prime axis. Let we solve these problems first. Okay. At first we write in the problems what the value are given here. So we can write here value of r is equal to 10 centimeter. So we convert 10 centimeter into meter, 0.1 meter, and mass is 4 kg. Okay, this is the enough information for solving one. Dear student, we know this is the own axis. Because of this axis, moment of inertia will be I is equal to mr square divided 2. This is very simple. So we write here solution C. Okay, we solve problem number C. Okay, we know moment of inertia x prime will be mr square divided 2. Why we write this equation? Because this is the own axis. Because of that reason, moment of inertia will be, in case of the cylinder, mr square divided 2. So we put the value m4, r is 0.1 whole square divided 2. After solving these problems, you get the value. Okay, let me find out this value. 4 into 0.1 whole square divided to 0.02. Okay. Our second problem. What is our second problem? Our second problem is change of moment of inertia for both axes. Okay, both axes respective moment of inertia কতটুকু চেঞ্জ হবে? তাহলে already we get the value. Okay, already we get the value from C. Now we solve D. Solution. Okay, from C we get x prime will be 0.02 kg meter square. This is equation 1. Now our duty is to find out the moment of inertia in case of the CD axis, and CD is the parallel axis. So we can write the formula. We can write our formula here. We know our formula is like this. If we find out the moment of inertia along AB axis, then we can write IAB is equal to, at first we write IZ and MS square. Okay, Ig means this is the Ig. Why this is Ig? Because this I exists passing through the center of the gravity. So suppose this is the center. So here has all the mass concentrate. So we can write on the Ig m r square divided 2. So we can put the value here, m r square divided 2 and m s square. So this is our equation to find out the moment of inertia along AB axis. Okay, now our duty is to find out the moment of inertia with the help of this equation. So we write here at first, actually this is the value of Ig. We know moment of inertia in case of the rotational axis AB. Okay, AB is equal to Ig plus m s square. The value of Ig will be 0.02 and value of m will be, what is the value, 4 kg, and distance of S is 0.0 centimeter. So we can write 4 kg and distance is 0.0 centimeter converted into meter, 1.5 whole square. So finally we get our desired value, 4 into 0.15 whole square plus 0.02. So our value is 0.11 kg meter square. So this is the value of AB. What will change of moment of inertia? That means in our previous moment of inertia 0.02, now if the cylinder rotates around AB axis, then moment of inertia will be 0.001. That means moment of inertia will be increased. How much amount of moment of inertia will be increased? So we can write I AB minus I x prime. IAB means 0.11 and 0.02. So change of moment of inertia will be minus 0.02. Our answer will be 0.09 kg meter square. Okay, my dear student, I think that all of you clearly understand. Okay, if all of you clearly understand, and then you can able to solve all the problems. Here already we solve a lot of the problems. Okay, example 2 already completed. My dear student, actually my suggestion to you, always try to apply parallel axis theorem. So this is very powerful theorem. According to these theorems, you can easily solve all the mathematical problems easily. In our next lecture, I also give you some special problems. Okay, thanks to all for watching my lecture very patiently. Okay, next day I will try to give you another problems, and you just try to practice this equation and practice these problems more and more again and again for gaining so much knowledge and develop your knowledge. If you want to develop your knowledge, then you must have to practice these special problems again and again. Okay, and try to always remember the basic formula and basic formula of the basic shape, and then try to find out the moment of inertia for different type of the axis with the help of two theorem. One is parallel axis theorem and another is perpendicular axis theorem. Always try to remember this. These two theorems is really very powerful for find out the moment of inertia for different type of the axis, different type of the rotational axis. I think that all of you clearly understand. Thanks to all for watching my lecture.